Welcome back to this video tutorial. We can discuss about the topic pointers in this video. So before starting this, we need to discuss or we need to consider again about certain topics that we have already learned in this subject. Okay, that is, here it is, the data types. We have three different types of data types: primary data type, user defined data type, and derived data types. Right, we have learned in detail about this primary data type in our previous video, and we have two more types like user defined data type and derived data type. And this derived data types, we have this pointers, arrays, structures, union, etc. Right, we have already discussed about this arrays, and this arrays follow the properties of this primary data type. So we can say that these derived data types are actually derived from this primary set of data types. Right, now we can discuss about this pointers, the second type of derived data type, which is also follow the properties of this primary data types in our language C. Okay. So before starting this pointers concept, we need to understand what is an address in programming. Okay, what is a memory address? If you have a variable var in your program, ampersand var will give you its address in the memory. Okay, if we have a particular variable, then ampersand of that variable, this particular notation will give you the address of that particular variable in the memory, or the memory location to which that variable is pointing. Okay, we have used this address numerous times while using the scanf function. Right, we have used this address notation in scanf function. The syntax is like this: scanf %d ampersand a. This ampersand a actually indicate the address location to which this variable a is pointing. Right, so consider this one, and suppose this is the memory representation. This is simply a notation. These are not the exact memory representation. Okay, for the explanation, I just introduce certain numbers as memory address here. Okay, so this is a program in which we have a variable or a character type variable var, which is initialized with value a character a. Right, after that, here it is the print statement for printing the value of variable, and here the second printf will print the address of ampersand of this variable. Right, what are the result? So while this declaration and initialization inside our memory system to particular memory location, which is labeled as var, or to particular memory location, a single byte of memory which is free now, we can assign our name, variable name var to that location. To that location we can store the character a. Usually the character type values are stored in memory using its ASCII code. Right, so here 1003 is the location which is now pointed by this variable. Okay, this var is pointing to this particular location to which we can store the value a. So a is character. So for the character type value, actually is ASCII codes are usually stored in memory. Right, so while executing this first print statement, what will display? It will display the value of this variable. That means this var actually pointing to this location. Here we have the value a. Right, so the first printf statement simply display this symbol a. Right, so after the first execution, the second printf will display what? Ampersand of var. What's the difference? Here it display the value to which this var pointing. That means this var pointing to this particular memory location 1003. This is the address of the memory byte which is pointed by VAR. Now here we have a value that is A, small letter A. Okay, so which is displayed here while executing the first printf, and after that while executing the second printf it will display the address of variable VAR. That means the address which is pointed by this VAR. That is, in this printf statement it will display the value 1003 based on this particular representation. Right? This ampersand VAR actually indicate the address of the variable that is pointing. This VAR is pointing to this particular location, so ampersand VAR indicate 1003 here. And simply this VAR indicate the value present in that location. So this VAR indicate the value A and ampersand VAR indicate the address to which this variable pointing, that is 1003 here. So this is about memory address in our system. Okay. So next is about the topic pointers. A pointer is a variable whose value is the address of another variable. So this is the definition of pointer. A pointer is a variable itself. Okay. Pointer is a variable whose value is the address of another variable. Right. That is the direct address of a memory location. So pointer is exactly like a variable. It follows all the properties of variables, but this pointer type variable hold the address of another variable or address of memory location. Right? So always keep in your mind this definition of pointer, right? Like any variable or constant, you must declare a pointer before using it to store any variable address. That means this pointer type variables are also variable itself, right? So it follow the properties of variable. Okay, so pointers must follow the properties of variable, so that before using a pointer type variable for storing the address information, we must declare first. Okay, the general form of a pointer variable declaration is like this. Just like our variable declaration, here we need to specify the type first, then the name of the variable. But here it is a pointer type variable. So use this asterisk symbol first. Asterisk symbol with this variable name. So this is the case of pointer type variable declaration. Here we have certain examples like this. Int star p. What's the meaning? P is an integer pointer. P is a pointer variable of type integer. X is a pointer variable of type float. And C is a pointer variable of type char. How to get or how to decide this is a variable or a pointer? Based on the presence of this asterisk symbols here, we can decide that these are pointer variables. That means these variables are declared here for storing the address of another integer variable or address of another floating point variable or address of another character type variable. Right? So, next is about assigning of memory address to pointers, or how to assign memory address to pointers. So consider one simple memory system representation. Okay, all these numbers are just assigned here for our explanation purpose, right? So the general format for pointer variable declaration is like this. Already discussed this. Type start variable name, right? So this is the declaration int star pc comma c. That means this pc with asterisk symbol indicate this pc is a pointer type variable of type int and c is simple integer variable, right? So suppose C is pointing to this particular location. This is integer type. We have already discussed an integer type variable assign 2 consecutive free memory bytes in our memory. And the first location is labeled with name C. So here suppose this 1000 and 1001. These are the two consecutive bytes that are allotted, and its starting address is labeled with the variable name C, right? And again we need one more variable which is also of type int. So another location 1004 and 1005. These two consecutive bytes are allotted here, and 1004 is labeled with the name PC. Okay, this PC is a pointer type integer variable and C is a simple integer variable. And next step, C equal to 5. That means the allotted bytes of our memory, that means the memory location pointed by C is, that is 1000 and 1001. These two consecutive bytes are used for storing this 5. That means this allotted bytes are initialized with value 5 now. Next, PC equal to address of C. Ampersand C means address of C, right? The address of C actually indicate the starting address among these two consecutive bytes, that is this 100, 1000. Okay, so PC is initialized with the address of C. So PC is now initialized with value this 1000. Using these two consecutive bytes pointed by PC is used for storing address of our integer variable C. Right, so its starting address actually is 1000, so which is stored here using these two consecutive bytes, right? PC is a pointer variable, integer type pointer variable, so it used to store the address of this integer variable C, right? Next is about get value of thing pointed by pointers. How to access the value using this pointer, that is our next topic. How to access value using this pointers. Okay, suppose consider the same example. C is a memory location. Here we have an integer 5, and PC is a pointer type integer variable which stores the address of this variable C, that is 1000 is stored here in this location. Okay, in order to get or access this value 5 using this pointer type variable PC, how to code? For accessing this, we can use this syntax, that is star PC. Star PC actually indicate the value present at memory location pointed by, the value available in this particular address location, right? PC is a pointer variable which now hold the address of another variable C, right? So star PC actually indicate the value present at this address location. Simply PC indicate this address 1000 and star PC indicate value present at this 1000, right? So while printing this star PC, what will return? It will display the value 5 because PC pointing to, or PC hold the value 1000. Okay, and star PC pointing to the value present in this particular location. The value present in this location is 5 actually. So this star PC display value 5. Simply PC display this address information and star PC display this 5, which is available in this particular memory location, that is available in PC now. Okay. So consider this int star PC comma C. PC is an integer pointer variable, C is an integer variable. C is pointing to here in this location 1000. That means two consecutive bytes starting from this 1000 is allotted and is labeled using this name C here. Okay, and C equal to 5. But what's the meaning? 5 is stored here using these two consecutive bytes. Next is about PC. PC is pointing to another location, right? PC is a pointer type variable. How to get? Because this asterisk symbol present here in this declaration that indicate that PC is an integer type pointer. Right, then PC is initialized with the address of C. So here in this location pointed by PC is loaded with the address of C, that is 1000. That is PC equal to address of C. After that, star PC equal to 1. This is another statement. While executing this one, what will happen? Star PC means value of this particular location, that is now available in PC. PC is loaded with the address information 1000. Okay, so simply PC indicate 1000, but star PC indicate value of this particular location. So here is the case, star PC equal to 1. That means we need to initialize a new value to the location available here. Here the address available is 1000. So here we need to store another value. That means we need to replace this 5 with a new value 1. Got it? So after this initialization, while printing this star PC will display the value 1. Star PC means move to this PC. Identify the address available here. And star PC means the value available this particular address, which is now available in PC. Value of this particular address location, that is star PC. And again print of C. While displaying C, it will also display the value currently available here. Currently here we have the value 1, so it simply display the value 1. Okay, so for getting the value of this particular location, we can simply use this variable name, or we can use this pointer within this asterisk symbol star PC. Okay, using these two we can access the value available here in this particular location. Okay, so these are about the pointer basics. Now we can consider this program example. Right, here we have a pointer variable P and is of type int. Okay, another variable here we have var equal to 10. Right, so var is a variable which is initialized with value 10. Okay, and star P is a pointer type variable. Now here V is P. This pointer P is initialized with the address of this variable. Right. So now consider these set of printf statement. Here in this first printf statement, value of variable var is displayed using this variable itself. What will it display? It will display the value 10 here. Next, we can display the variable value var value using this star P, because P is pointing to address of variable. So star P indicate the value available in that particular address location. Okay, next address of variable var is displayed using ampersand var. That means address of var. Okay, this address information is also available in pointer P. So we can display the address also by using this pointer P. Okay. Next, address of pointer P is actually P is a variable that pointing to particular memory location. Right? That address information, that is P is pointing, is displayed using this statement, that is address of P. So in order to identify the difference, we can now execute this. Okay, just analyze. Value of the variable var is 10 by executing this. That is this var with value 10. Then again star P means P is pointing to the address, P is holding the address of this var. So star P means the value available in that particular location, that is 10. So again displayed 10. right? Next, address of variable, that is displayed using ampersand var. So this is the exact memory address of particular bytes in our memory, in which that location is pointed by this var now, right? So address of the variable again displayed using p. That's the meaning. P is a pointer. This P currently holding address of this var. So P pointing or P display the exact address information of our variable var. And the last printf actually indicate address of pointer P. That means P is a variable, is a pointer type variable. So P always pointing to a particular memory location. Okay, where we can store the address of another variable. Here we can store the address of this variable var. Okay, so the address of that particular location pointed by p is displayed here using this ampersand p. So that address is this. This is different from this. Okay, so keep in mind all these syntax and the meaning of all these representation. Variable star p means value available to that location which is held by p now. This is address of variable. This p actually indicate this address of variable itself, because p is initialized with address of variable, and ampersand p indicate the address of p pointing now, or address of memory location pointed by p now. Okay, so understand the difference of each of this representation. Thank you.